All right, here are solutions for quiz 5 for Math 213. This is our surface area quiz. So you find in the surface area of a couple different shapes, solids, I guess. And this first one is a cone, and specifically a cone with height 5 and base radius of 12. So, see how well I can draw three-dimensionally. Sure, not very well. That is the base of my cone right there, and that depicts its height. And we are told that the height is exactly 5 and the radius, so not to scale here, is 12. And what you're asked to do is determine its surface area. I guess I should fix that. By following the steps below. So first you determine the slant height. The slant height is the distance from any point on the perimeter of the circle that makes up your base to the apex up here. So how long is this line right here? And the way you can figure that out is you have a triangle, a very special triangle, a right triangle. This is 5 and this is 12. So you can solve for this length right here. Maybe I'll put it as c, because you know a squared plus b squared equals c squared. So you got 5 squared plus 12 squared equals c squared. So 169, I think, is what you get if you sum up those guys, is equal to c squared. So therefore c is equal to 13. Really plus or minus 13, but since we're talking about a length, it's got to be positive, so it's 13. So determine the slant height, 13. Units, I guess, if you want. I'll leave a little bit of room so I can write units. Not that important, but note that it is a one-dimensional measure when we're talking about height. All right, now let's get the slant height. Sketch a little circle. I can do that. And some portion of a big circle. So, all right, there's my big circle. But I don't want the whole thing. I just want some portion of it. So maybe I'll do something like this. And this stuff is gone. That can be put together to build the cone. Label the radius of both circles. So this bottom circle here is my base, so it has radius 12. And then this will end up being the outside of the cone. If this were gone, I could kind of fold this up. This would be the apex right here. And so the radius here would be 13. Determine the portion of the big circle that you are using. So what do I have left over here? Well, circumference. Let's see, how should I write this? Okay, if you were to fold up this cone right here, the distance from here, the arc length from here all the way over to here, that ends up being the circle down on the bottom here. So if I could figure out the circumference of the small circle, the circumference of the base, maybe I would say that that is 2 pi r is the formula for the circumference of a base. And in this case, r is equal to 12. So I get 24 pi. So what that ends up telling me is the distance from, maybe this is A, B, which is arc length of the arc from A to B, this side of it anyways. What about the circumference of this whole circle? Circumference of big circle. Kind of says circle. Well, it's the same idea that the circumference is 2 times pi times r. But now r, instead of being equal to 12, is equal to 13. So I get 26 pi. So to determine the portion used is 24 pi divided by 26 pi, aka 12/13 if you reduce this fraction. And you might choose to put that into a decimal if you want. It's kind of an ugly decimal, so I'll leave my answer like that. All right, determine the area of the little circle. The area of the little circle is the area of the base, and the area of any circle is pi r squared. R in this case is equal to 12, so I get 144 pi. Determine the area of the portion of the big circle that you're using. Okay, so portion of the big circle is 12/13. I don't want the entire circle. I only want 12/13 of it. Of the big circle's area, which would be pi times r squared, r being 13 in this case. So I get, this is 169. Times pi times 12/13. Can I do that in my head? I can, because one of these 13s cancels one of these 13s, so I'll have a 13 in the denominator. No, I won't. I won't have any 13s in the denominator. That canceled out. And 12 times 13 is 156, I think. I think that's 156 pi if you multiply these guys all together. So state your final answer for the surface area of the cone. Well, it's 144 pi plus 156 pi. And that's going to end up being a really nice number, I think. That's 300 pi, yeah? Yeah, cool. And I guess these would be units squared. Although I don't care all that much. 300 pi is fine. So I guess that's the end of the cone problem. We'll move on to a pyramid problem. So here you're determining the surface area of a pyramid with a rectangular base. That was kind of mean. Got a lot of practice with square bases and some other bases. I hadn't seen a rectangular base until now. But here's your pyramid with a rectangular base. Not the greatest drawing in the world. I can even put the height in here for you if you would like. The base measures 10 by 18, so maybe I'll call this 18 and I'll call this 10, and the height here is 12. I don't know where to put that. 12, sure, that height. And what you're asked to do is figure out the surface area. Well, the surface area comes from kind of 5 different parts. I have these 4 triangles on the bottom, and then I have the base. So let's start out with the base area. That's the easiest. Because it's a rectangle, I just take the length times the width. 10 times 18 gives me 180. Then I got 4 triangles. 2 of them are bigger than the other 2, so maybe I need to do this off to the side. I need to know some slant heights. So I can figure out this slant height. Maybe I'll call this the I don't know, slant height 1. And the way I can figure that out is I have this triangle here. And in this triangle, the height is 12. And this length right here is 9 because it would be half of this 18. And what I have to do is figure out this. Maybe I'll put it in as C. 12 squared plus 9 squared is equal to C squared. 144 plus 81 is equal to 225. So let's do it this way. So 225 is equal to C squared, and therefore C is equal to 15. So slant height 1 is 15. This length right here is 15. But there's another slant height that I'm going to be interested in, and it's this guy here. Slant height 2. I also have a triangle. Now my triangle, let's try to orient it a little bit. Still has a height of 12, so I'll leave that as a 12. This length right here, this other leg, is half of this 10, so it's 5. And I think we've already seen a right triangle that had lengths 5 and 12. We saw this was 13. Maybe I'll say C above, C question 1. For where that 13 comes from, even though it looks like a B, it's a 13. Okay, so now what I can do with those slant heights is I can figure out the area of the triangle. I got area of front triangle. Triangles, maybe, because there's 2 of them. There's one, now front doesn't make sense. Whatever. There's the front one and the back one, and each of them have a height of 13, so 2 of them times 1/2 times the base. The base will be this distance right here, which is 18, times the height, which will be this 13. And 18 times 13, I can't do that in my head. We'll pull out a calculator. That's equal to 234. I also have side triangles. And they're only sides because of the way I drew this thing. Again, there's 2 of them. And they follow the formula 1/2 times the base times the height. The base here is going to be this 10. And the height here will be the slant height that I calculated over here in red, which is going to be 15. So that is going to be equal to 150. So if I sum up those numbers, total surface area is equal to 180 plus 234 plus 150. And that is equal to, it ends in a 4. 5 plus 3 is 8, plus 8 more is 16. Carry the 1. 564, I think, units squared. Ends up being the surface area, this rectangular pyramid. Pretty hard problem, I think. You have to have a pretty good conceptual understanding of slant heights and how these all work and where your Pythagorean theorem comes in. So we'll see how that one goes, but I suspect this one will go quite well since we went over this exact thing in class. So I guess I'll end the solutions here.